What's up, everybody? We're back here on Mr. Murray's Mathland, and we are continuing on with trigonometry in the pre-calculus level or Algebra 2 level even. But to do so, we're really just going to review some basic geometry today. You know, a big part of that unit circle and what's coming up really just comes back to these special right triangles. So it's worth taking a moment, reviewing that good old geometry, right? It's what the acorn said when he grew up, geometry. So let's do a little bit here. The 45, 45, 90 triangle here, you know, hopefully you kind of remember these relationships that two angles congruent means two sides congruent. So that's an isosceles right triangle. So right off the bat, you should know that these two sides are congruent. X and X, whatever that one is, no matter how weird they might be. And the hypotenuse, which you could always do the Pythagorean theorem to find if you knew that. But it's nice to remember, that's like the diagonal of a square also, is always going to be that leg of x multiplied by root 2. It's always going to have that relationship. No matter what this side is, its hypotenuse is going to be that same side, but times root 2. That's it. Okay, so that's usually a pretty easy one, and if you remember all your kind of, you know, trig relationships, sine, cosine, tangent, etc., you may kind of notice, oh, the ones with root 2 in it are always the 45 ones, the families of 45. So let's go on to the 30, 60, 90, the other one. Now, this has three different angles, 30, 60, 90. Whatever's across from 30 is going to be the shortest side or the short leg, and whatever's across from 60 will be the medium side, or the long leg, right? These two are legs. So we have a short leg and a long leg. And whatever's across from 90 is, of course, the hypotenuse, which is the longest side of the three. So this is going to, this one takes a little bit more memorizing, but I just like to say, remember that it comes from half of an equilateral triangle. That's what's happening here. If you have an equilateral triangle, these are all 60 degrees, 60 degrees, 60 degrees, and all three sides are the same. But when you drop an altitude right down the middle, it splits that 60-degree angle at the top into 30 and 30, and it splits this side on the bottom into two equal pieces. So whatever this hypotenuse is, this is half of it. And to me, that's a great place to start here, that whatever this side is, it's half of the hypotenuse. Whatever's across from 30, the short leg, so we call that x. That hypotenuse is always going to be double that length, 2x and x. And the long leg, you can do Pythagorean theorem, of course, if you know two sides, and you could find this. But what you always are going to find is that altitude is x root 3. It's whatever this side is, whatever that short leg is, but multiplied by root 3. A little bit longer, but not as long as multiplying it by 2. That's going to give you the hypotenuse. So there's your relationships you need to know. And we're just going to take a look at a couple problems that pop up that use that before we even get into anything with sine, cosine, or tangent. Just kind of getting comfortable with angles and standard position. And so here's one question here. -5, -5 is on the terminal side of an angle theta in standard position. Give the value of theta in degrees and radians. Let's be comfortable here. So -5, -5, hopefully you're totally comfortable thinking that is in quadrant 3, right? So -5, 5 to the left, 5 down is going to put you right there just for a little sketch here. And what I always like to do, I like to make an altitude with the nearest x-axis. So I like to make a right triangle. And that side was, 5 or -5, and this side was, 5 or -5, depending if you want to include the negative or not. But the important thing is that the lengths of those segments are equal. So if those two sides are equal, you're dealing with an isosceles right triangle, which means you got yourself a 45, 45, 90 triangle. And the angle I'm really going to focus on in these problems is the one with the nearest x-axis. We call that the reference angle in these kinds of problems on the coordinate plane. So that angle is 45 degrees, but that's not the answer you're looking for. Just keep in mind, you're looking for theta, and theta is the angle in standard position that will put you there. And it probably should say that theta is, between 0 and 360. It usually will say something like that. So this is theta, from the right side of the x-axis, that's standard position. What is this angle to put you in this location? So you're 45 degrees past 180 right here, right? So very easy. That theta is 180 plus that 45. And so that's going to give you 225. And from there, you want to answer in radians. And this might be one of those things where you just know, you've done this conversion a lot of times, 225 degrees. You can do 225 degrees and then convert using that formula, which is multiplying by pi over 180, doing the fraction of 225 over 180 and realizing that, those are multiples of 45. You also could do this. If that seems like a difficult fraction for you to contend with, keep in mind what 45 degrees is in radians. Using an easier, more familiar amount, 45 degrees is pi over 4, and 180 in radians is pi. So you're just going pi plus an extra fourth. So you've got a few options with how to arrive at this answer. Pi plus pi over 4, 1 and a fourth is 5/4. So that's 5 pi over 4 radians. 225 degrees or 5 pi over 4. And that, of course, is what you would get if you reduced, 225 over 180. 45 goes into there 4. 45 goes into there, goes into 225, 5, and 184. So I'm kind of a bigger fan of thinking of the pi plus that little reference angle. And the more comfortable you get with the unit circle, these values all start to become super familiar, all the pi over 4s in each quadrant. But we'll talk more about that as we go. And now let's just see one more example just for practice. How about this? 7, -7 root 3. First things first, I'm a big fan of drawing the diagram and visualizing to make sure your answers make sense. We are in quadrant 4. When you really get comfortable with these, of course, you don't have to draw a diagram. But 7, -7 root 3 will be going 7 to the right and down 7 root 3. So that would be, going over to the right a little and down a lot. So when I make my right triangle with the x-axis, I went 7 to the right and 7 root 3 down. Again, the negative kind of told you the direction, but it's the 7 root 3 you care about. And so you've got yourself a right triangle with a relationship of x root 3. The important thing is you got a 30, 60, 90, but what is that angle right there? So that reference angle, as we call it, it's across from the x root 3, the longer leg. That's 60 degrees. So your answer, remember, is not the reference angle, but it's what's the angle that will put you in that position from standard position. So going all the way around the circle to quadrant 4, it's going to be something between 270 and 360, right? 270 is down here. And so you are 60 degrees shy of being 360, right? So 360 minus 60, going to give you 300 degrees. So that's why this reference angle is so important. When you're in quadrant 3, like in the last problem, you're going to add it on to 180. If you're in quadrant 4, you're basically subtracting from 360, getting 300. If you were in quadrant 2, you would, subtract that amount from 180, because you're always trying to see how far away from the nearest x-axis are you. That's really what's going on. And to do this in radians, again, you could convert if you want. Take your 300 and multiply by pi over 180, right? Just kind of reducing that fraction. That's a pretty simple way to go, right? You can cancel those zeros. Love when they got zeros on the end. And 30 divided by 18 just reduces to 6 goes into each of them, 5 pi over 3. That's one way, is just taking your degree value and converting. But as I said in the last problem, I'm also a big fan of thinking about what these are. 60 degrees is pi over 3. That's kind of one you should be comfortable with. And 360 is 2 pi. So you could just take, just like we did with degrees, take your 2 pi and subtract your pi over 3, right? That pi over 3, I'm 1/3 of pi away from being a full 2 pi. So what's 2 pi minus pi over 3? Hey, 2 minus 1/3, right? 6/3 minus 1/3 is 5/3, or 5 pi over 3. So whatever works easiest for you, more than one way, maybe you use one way to check yourself, whatever way you're most comfortable with, and then use the second way to kind of check and convince yourself. So there we go, that's that. Hopefully, easy stuff and is making sense, but as always, if you got any questions, just let me know.